Hello students, I hope you are all doing well. I welcome all of you for the today's class. In the last class, we had seen how to find the squares of the given number. And so, whenever we have the length of a side of a square, we can always find the area of a square. But if the area of a square is being given, can we find the length of a side of the square? Yes, we will discuss about it in the today's class. But before that, I have another question. Suppose in a right angle triangle, if a hypotenuse and a side of a triangle is given to be 5 and 3 units respectively, can we find the other side of the right angle triangle? Think about it. Yes, we can find by using the Pythagoras theorem. Do you all remember Pythagoras theorem? Well, let me state it for you. Pythagoras theorem states, in a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of other two sides. So now, by using this Pythagoras theorem, let us try to solve it. Look at the given right angle triangle. So here we were given with hypotenuse to be 5 centimeter, and let us consider one of the side to be 3 centimeter. So now by Pythagoras theorem we can write it as 5 square is equal to 3 square plus x square. Upon simplification, we can write this as x square is equal to 25 minus 9, which implies x square is equal to 16. So now we need to find a x whose square is equal to 16. Students, can we find a number whose square is equal to 16? Well, we will also address this in the today's class. So now, if you observe these two problems, the first one, whenever the area of a square is been given, can we find its length of a side? And the second one, in a right angle triangle, when the hypotenuse and one of a side is been given, can we find the other side? So these sort of questions needs a number whose square is been known. So we will try to discuss more about this in today's class, which is about the square roots. Students, finding a number whose square is known is called as finding the square root, and the number which we find is the square root of a given number. So remember, we already know that
subtraction is the reverse process of addition.
In fact, we also know that division is the inverse of multiplication. In a similar way, finding the square root is the inverse of squaring. So now let us try to look at some of the examples. So we know that 1 square is equal to 1. So therefore 1 is the square root of 1. Next, we also know that 2 square is equal to 4. Then 2 is the square root of 4. In a similar way, we have 3 square is equal to 9, which means 3 is the square root of 9. Students, we will denote this square root by the way which is being displayed on the screen. So that is what the symbol which we use for denoting a square root. Well, now let us try to look at the examples by using the way we denote the square root. So here we have square root of 9 is equal to 3, square root of 64 is equal to 8, square root of 81 is equal to 9. So in a similar way, you can try to list more number of examples. Well, now let us try to discuss more about the ways of finding the square roots of a given numbers. In fact, there are many methods which could be discussed, among which let us try to discuss few of them. So firstly, let us try to discuss a method of finding the square root by using repeated subtraction. Well, so in this method of finding the square root through repeated subtraction, we will make use of some of the known ideas. We have already seen that the sum of first n odd natural numbers is given by, well, that is n square. So, that means any square number can be written as the sum of successive odd natural numbers starting from 1. We make use of this idea to find the square root of a given number using repeated subtraction. So, let us try to look at this method by taking an example. So, here let us find out the square root of 25. You observe the following subtractions: 25 minus 1 is equal to 24, 24 minus 3 is equal to 21, 21 minus 5 is equal to 16, 16 minus 7 is equal to 9, and finally 9 minus 9 is equal to 0. So, if you observe all these subtractions, from 25 we have subtracted successive odd numbers starting from 1, and so we obtain 0 at the 5th step. Make a count of it, it is the 5th step. So, therefore, we found square root of 25 is equal to 5. Students, we had seen how to find out the square root of a given number through repeated subtraction by taking up an example. So, what we did here is we took the number and we started subtracting the numbers, in fact the odd numbers successively from 1 and so on, and whichever the step where we got 0 at the end, we considered that numbered step as the answer. So, to make it more clear, let us try to look at one more example. So, now let us try to find out the square root of 64. So, as we did earlier, let us try subtracting the numbers, the odd numbers starting from 1 and so on. So, we start with 64 minus 1, which is equal to 63, 63 minus 3 is equal to 60, and so if you keep repeating the same process, at the 8th step we get 15 minus 15, which is equal to 0. So, here we end up with 0 at the 8th step. So, therefore, square root of 64 is equal to 8. Students, now we have found the way of finding the square root through repeated subtractions. So, if I give you any number, will you be able to find out its square root? Well, let me give you 729. So, can you find out the square root of 729 through repeated subtraction? Yes, we can find it, but then it is little tedious because it involves so many subtractions. So, then do we have any other simpler method where we can actually find out the square roots? Yes, we do have it. So, now we will discuss the second method of finding the square roots by using factorization. Yes, now we will discuss the second method of finding the square roots through prime factorization. Students, let us try to observe the prime factorization of some of the numbers and their squares. Upon observing, let us try to discuss, is there any method or a way of finding their square roots. Look at the following table. So, in the given table, the left column represents the prime factorization of a number and the right column represents the prime factorization of its square. Now, look at the number 6, whose prime factorization is given by 2 multiplied with 3. Observe its square, which is 36 on the right column, whose prime factorization is given by 2 multiplied with 2 multiplied with 3 and then multiplied with 3. Now, next let us consider the number 8, whose prime factorization is given by 2 times 2 times 2. Now, consider the square of 8, which is 64, and its prime factorization is given by 2 times 2 times 2 times 2 times 2 times 2. So, in a similar way, we can also observe 12, whose prime factorization is given by 2 times 3, and consider the square of 12, which is 144, whose prime factorization is given by 2 times, 2 times, 2 times, 2 times, 3 times 3. And in a similar way, we can also observe that 15 has the prime factorization 3 times 5, and the square of 15, which is 225, has the prime factorization 3 times 3 times 5 times 5. Students, in the given table, let us try to observe the prime factorization of the numbers and their squares, and let us try to infer some of the interesting facts in it. In the prime factorization of 6, 3 occurs once, whereas in the prime factorization of 36, 3 occurs twice. You also try to look into the prime factorization of 12, where it is clear that 2 occurs twice, but in 144, which is the square of 12, 2 occurs 4 times, and even observe 3. In the prime factorization of 12, 3 occurs only once, but then in the prime factorization of 12, 3 occurs twice.
Every prime factor in the prime factorization of a square number occurs twice the number of times it occurs in the number itself.
You also observe 3 in the prime factorization of 12, where it occurs only once, but in the prime factorization of 144, it occurs twice. Students, we can observe that every prime factor in the prime factorization of a square number occurs twice the number of times the prime factor occurs in the prime factorization of a given number. So, that is what we can conclude from the given table. So, now we will make use of this idea and find out a way where we can find out its square root of a given number. So, now we will make use of this way and then try to find out the square roots of the given number. Say for example, if we consider 6, we know that its prime factorization is 2 times 3, and if you look into its square, which is 36, the prime factorization is 2 times 2 times 3 times 3. So, which can be written as 2 times 3 whole square. So, therefore, we have written 36 as 2 times 3 whole square. Observe these two things, students. The prime factorization of 6 was 2 times 3, and then we got the prime factorization of 36 to be 2 times 3 whole square. Well, now we have got the idea to find out the square roots through prime factorization. Now, to make this idea more clear, let us try to solve a problem by using this method. So, now find the square root of 324. Students, to find the square root of 324, firstly we need the prime factorization of 324. So, now let us find the prime factorization of 324. So, we know that 324 is divisible by 2 by 162 times, and now 2 divides 162 by 81 times. Now, 81 is divisible by 3 27 times, 27 is divisible by 3 9 times, and finally 3 divides 9 3 times. If you try to observe all the prime factors, we have obtained 324 is equal to 2 times 2 times 3 times 3 times 3 times 3. Now, let us try to look them in pairs. Observe clearly, the first two 2's will write it as 2 square multiplied with the next 3 times 3 we will write it as 3 square multiplied with, and the last 3 multiplied with 3 we will write it as 3 square. So, this we can rewrite it as 2 times 3 times 3 whole square. So, we have obtained the square root of 324 is equal to 2 times 3 times 3, which is equal to 18. Students, we have found the square root of 324 using the prime factorization. Now, let us also look into another problem. Check whether the 45 is a perfect square. If it is not a perfect square, find out the least multiple of 45 which is a perfect square. So, the problem is 45 a perfect square? If not, find the smallest multiple of 45 which is a perfect square. So, now let us try to look into the prime factorization of 45. So, we know that 3 divides 45 15 times and then 3 also divides 15 5 times. So, by this we can write the 45 as 3 times 5. So, here we obtain the prime factorization of 45. So, observe the prime factors in the prime factorization of 45. Clearly 3 occurs in pairs, but then the prime factor 5 does not occur in pair. So, this gives an idea that 45 is not a perfect square. Students, we have found that 45 is not a perfect square. Why? We had 5 in the prime factorization which occurred only once. Now, the next task was we need to find out the smallest multiple of 45 which is a perfect square. How can we make it as a perfect square? So, when all the prime factors occurs in pairs, we are done. So, now in the prime factorization of 45, 5 occurred only once. So, if we multiply this with 5, we will get a number which is a perfect square. So, therefore, the 45 multiplied with 5, we get 225 which is a perfect square, and in fact, the square root of 225 is given by 3 times 5 which is equal to 15. Students, now let us consider the number which I had given you earlier. I had asked you to find out the square root of 729, but which was bit tedious. So, now we can find out by using this method. So, look at the prime factorization of 729. So, if you observe 729, it is divisible by 3 by 243 times. 3 divides 243 81 times, 3 divides 81 27 times, 3 divides 27 9 times, and finally 3 divides 9 3 times. So, the prime factorization of 729 is equal to 3 multiplied with 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 3. If we write them in pairs, so 3 square multiplied with 3 square multiplied with 3 square. So, which we can rewrite as 3 times 3 times 3 whole square. So, therefore, we can find the square root of 729 is equal to 3 times 3 which is equal to 27. So, yes, though using the repeated subtraction it was difficult to find the square root of 729, using the prime factorization we had easily found that square root of 729 is equal to 27. Well students, now let us try to solve some of the very interesting word problems. So, look at the problem number 1. The problem goes like this. The students of class 8 of a school donated rupees 2401 for Prime Minister's National Relief Fund. Each student donated as many rupees as the number of students in class. Find the number of students in the class. Students, to solve this problem, let us try to make a note of the given information. So, if you observe, it is given that total amount of money donated is equal to rupees 2401. It is also given that each student donated as many rupees as the number of students in the class. To solve this problem, suppose if the number of students in the class is equal to x, then by the given information, amount of money donated by each student will also be equal to rupees x. So, therefore, we can write x square is equal to 2401. So, this implies x is equal to square root of 2401. Yes students, we have got x is equal to square root of 2401. So, therefore, to find the value of x, we need to find what is the square root of 2401. So, we have observed the finding the square root by using prime factorization. So, now let us try to find out what is the square root of 2401 by using prime factorization. To find out this, we know that initially we need to find out the prime factorization of 2401. Let us find it out. We know that 2401 is divisible by the prime number 7. So, 7 divides 2401 by 343 times. So, 7 also divides 343 by 49 times. Now, 7 divides 49 7 times. So, finally 7 divides 7 1 time. So, thereby we got the prime factorization of 2401 to be 2401 is equal to 7 times 7 times 7 times 7. So, now if we make them in pairs, we have got 7 square multiplied with 7 square, which can be written as 7 multiplied with 7 whole square. So, we have got 2401 is equal to 7 times 7 whole square, which implies square root of 2401 is equal to 7 times 7, which is nothing but 49. Yes students, we have found that the square root of 2401 is nothing but 49. So, we have got the value of x. X is nothing but square root of 2401, which is nothing but 49. So, therefore, we have found the number of students in the class which we have considered it to be x, which is nothing but 49. Therefore, there are 49 students in the class. Well students, now let us try to see another problem. So, the problem goes like this. 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. Find the number of rows and the number of plants in each row. Students, so to solve this problem, firstly let us try to write down the given information. So, it is given that number of plants to be planted in the garden is equal to 2025. So, it is also mentioned that number of plants in each row is equal to the number of rows. Suppose if we consider the number of plants in each row is equal to x, then number of rows is also equal to x. Hence, the total number of plants is given by the number of rows multiplied with number of plants in each row. So, that will be equal to 2025. Just now we have considered the number of rows to be x and also the number of plants in each row will be x. Therefore, we will get x multiplied with x is equal to 2025. So, which implies x square is equal to 2025. Therefore, x will be equal to square root of 2025. Yes students, to find the value of x, we need to find out the square root of 2025. So, again we will use finding the square root through prime factorization and find the value of square root of 2025. So, to do this, we know that initially we have to find the prime factorization of 2025. Let us do it. So, 3 divides 2025 by 675 times. 3 also divides 675 by 225 times. 3 divides 225 by 75 times and 3 also divides 75 by 25 times. So, now 5 divides 25 by 5 times and finally 5 divides 5 by 1 time. So, therefore, we have got 2025 is equal to 3 multiplied with 3 multiplied with 3 multiplied with 3 and finally multiplied with 5 multiplied with 5. So, now if we pair them, it becomes 3 square multiplied with 3 square multiplied with 5 square, which can be written as 3 times 3 times 5 whole square. So, therefore, we have obtained 2025 is equal to 3 times 3 times 5 whole square, which implies the square root of 2025 is equal to 3 times 3 times 5, which is equal to 45. Hence, we have found the square root of 2025 is equal to 45. So, therefore, the number of rows is equal to x, which is equal to 45, and also the number of plants in each row is equal to x, which is also equal to 45. Students, If we consider the bigger numbers, even this method of finding the square roots through prime factorization becomes very lengthy and difficult. So therefore, we are in a need to explore the new methods which can simplify things. But we will find it out in the next class. Before we wind today's class, let's try to recollect what all things we have learned today. Yes students, we have started with the definition of the square root. Then we moved on to finding the square root through repeated subtraction. After that, we found the method of finding the square roots through prime factorization. And finally, we have also solved the word problems based on these methods. Hope you had enjoyed the class. Thank you.